This lesson is on section 5.4, inverses, contrapositives, and indirect reasoning. This is an extension of the lesson from chapter 2 that was on converses of statements and conditionals and biconditionals. We're going to start by learning a new word. The new word is negation. It means to take the opposite value of the statement. An example would be of an original statement would be Mr. Cron is a Twins fan. The negation of that would be to take the opposite value of the statement. So in this case, it would be Mr. Cron is not a Twins fan. The second one, Mrs. Stark has 2 sons. The negation of that would be Mrs. Stark does not have 2 sons. So you can see that sometimes, due to grammar and other English rules, you have to change the sentence a little bit. You can't just add the word not each time. We are also going to learn what the inverse of a conditional statement is. The inverse means you take the negation of both the hypothesis and the conclusion. So that means that you're going to take the opposite value of the hypothesis and the opposite value of the conclusion. The conditional, however, will remain in the correct order. Okay? If my conditional is, if it is snowing, then it is cold outside. The inverse of that would be to take the opposite value of snowing and the opposite value of cold. So it would be, if it is not snowing, then it is not cold outside. The other word we're going to learn is contrapositive. The contrapositive of a conditional statement not only negates both the hypothesis and the conclusion, but it also switches them. The contrapositive is actually a combination of the inverse and the converse that we learned back in chapter 2. So the contrapositive of this conditional statement would be to not only take the opposite value of the hypothesis and the conclusion, but then also switch the two. So the contrapositive would be, if it is not cold outside, then it is not snowing. Okay, let's try with this one. If a figure is a square, then its sides are congruent. The inverse would be to take the negation of the hypothesis and the conclusion. So it would read, if the figure is not a square, then its sides are not congruent. The contrapositive would take the inverse and then switch the hypothesis and the conclusion. So the contrapositive would read, if the figure is not congruent, if the figure does not have congruent sides, then it is not a square. The contrapositive of a conditional statement always has the same truth value as the original conditional. We call them equivalent statements because they always have the same truth value. The symbols for negation look like the Spanish tilde. So the symbols for the following statements are, if you remember back from conditionals, we say if P, then Q. The negation of P would look like symbol P. We say that that's not P is the way we say it. The inverse would read, if not P, then not Q. Notice the negation of each of them. And the contrapositive would be the converse of the inverse, so to speak. It would read, if not Q, then not P. We can also use the negation in something called indirect reasoning. In indirect reasoning, all possibilities are considered, but then all of them except one are proven to be false. Usually, in an indirect proof, which is a way to show indirect reasoning, there are only two possibilities. Either the statement is true or its negation is true, its opposite. So if you're going to write an indirect proof, the steps that you would follow are take your statement and one, assume the opposite of what you're trying to prove is true. So in other words, use the negation of it. Then show that that assumption can't work, show that it's false. And so by showing that's false, you can conclude that originally what you were trying to prove then is a true statement. So if I wanted to write the first step of an indirect proof of this, what would be my first step? I would want to negate this sentence. What I'm trying to prove is a triangle cannot contain two right angles. So my first statement would be to write that a triangle can contain two right angles. If I was going to do an indirect proof, I would then go on to show that a triangle cannot contain two right angles, therefore proving what I was trying to prove. One thing that you try and get down to is something called a contradiction. If two statements contradict each other, then you know that that can't be true. So if I was going to identify which two of these statements cannot be true at the same time, that FG is parallel to KL, that FG is perpendicular to KL, and that FG is congruent to KL. Which two of these cannot happen at the same time? The answer would be two lines cannot be parallel and perpendicular at the same time. Going through an entire proof of an indirect proof, you would start with, what I'm trying to prove is triangle ABC cannot contain two obtuse angles. So I would start in step one by saying the negation of that statement. I would assume that two of my angles, let's say A and B, are both obtuse angles, which means they both are greater than 90 degrees. I would then try and find a contradiction. Since angle A and B are already greater than 180, since they each have to be greater than 90, that means that the sum of all three angles would have to be more than 180. And we know that that can't be true because we know that the three angles of a triangle do add up to 180 and no more. So since that's a contradiction, our assumption is false. Therefore, we know that triangle ABC cannot have two obtuse angles. That is how an indirect proof works. The homework for section 5.4 is as follows.